there's another thing you should know is how many zeros will there be at the end when you take 100 factorial? You can kind of think, oh, 100 factorial is 100 times 99 times 98 times da 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 da, and 10 and da 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 da, 3 times 2 times 1. So obviously there will be 3 zeros for sure. Okay, but as it turns out, here's the answer. I made it easier to count 5, 10, 15, 20. There are 24 zeros. Is there any way to find this out without doing the problem? Yes. These zeros come from fact that you're, as you saw, multiplying by tens here. But thing is, you got to do more than that. What is 10 made of? 10 is made of 2 and 5. So what you have to do is you got to see how many 2 and 5 you got multiplied here. As it turns out, when you do factorial business like that, every other number has 2 in it because it's an even number. So what we do is that we ignore 2. There will be just plenty of supplies of 2s coming in. There will be 50 of them for you coming in. So we don't care about 2s. There are just a lot of it. We'll care about 5s. How many 5s are there is the question. Okay, let's see. Well, there's 100 number. Every fifth number is 5, isn't it? So we say, oh, 5, 10. If I divide by 5, what do we get? I have 2, 0. I get 25. So that's how many zeros I would get. Okay. But how come there's 24? The reason is this. Some of the 5s you had here, well, you're right. Even 10 and 100 here is taken care of by 5. Because let me show you how I can show you here. The factorial, 100 factorial, let's start from beginning here. 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8 times 9 times 10 times 11, 12, 13, 14, 15, and so on. It goes here, right? This guy is responsible for giving you 10, because a 2 and 5 would give you 10. This guy was responsible for giving you 10 because he is 10, but it had 5 in it, right? And this was also responsible for giving you 10 because this was made of 3 and 5. And right next guy has 2 in it. So multiply it, get 5. But the thing is this. If you go 2 more, there was a number called 25. And yes, it was responsible for giving you 5 because it had 5 in it, but it had another 5. This guy gave you 2 tens. This guy gave you 100. So there are pesky numbers that are giving you more than 1 tens. So they are namely 25. So you say, oh, there are 4 25s that gives me multiples of 25 that generates extra tens for me. See, first 10 was given up by this, right? The 25, when you discovered that, oh, you are a multiple of 5, you are giving me 10. Yes, it got counted here. But there was a leftover that didn't get counted, and there were 4 of them. So therefore, there were 24 altogether. If this was a longer one, then you would have gone to 125, because 125 has 3 5s in it. If it was even longer, then you would divide by 625, because this had another 5 in it. Good. So whenever you are having this whole sequence of number, like factorial, and you're looking for a number of zeros, you are looking for multiple of 5s. But you are not only multiple of 5s. You have to hunt down the numbers that are giving you 2 5s, 3 5s, 4 5s until you run completely out of 5s. Only then you can say, I know how many zeros it has at the end. Then again, 5 doesn't give you 0, 10 gives you 0, but there are plenty of 2s all around. Look at this. We had only 24 5s, but how many 2s did we have? We had, well, at least 50 to start with, but then again, numbers like 4 had 2 2s in it, number like 8 had 3 2s in it, basically plenty of 2s. So we don't care how many 2s there are, just count 5s. Make sure you count one that gives once, gives it twice, 3 times, 4 times, 5 times, 6 times, whatever it takes. Count them, and you will know how many zeros it has at the end.